Another important set operation is complement of a set. Let's see how it is stated. It is stated as complement of set A, of any set A, it could be any given set, of set A refers to elements not in A, okay. It is also stated as complement of A is the set of elements of universal set that are not element of A, that are not element of A. Universal set is any given set of which the set A is the subset. Okay, we will see it in example for your convenience. Now we'll see its representation. Mathematical representation is how you can represent mathematically. Mathematical representation is given as, you can represent it mathematically as A complement is equals to U minus A. Okay, it is also written as A dash is equals to U minus A. It is also written as A bar is equals to U minus A. These are the different ways of writing at various places. Besides A, if you have B, you can write it as same. B complement is equal to U minus B. Again, B dash is equals to U minus B, and B bar is U minus B. Okay, this is how you can represent a complement of a set mathematically. Let's see how you can represent it in the form of Venn diagram. So Venn diagram representation is let's see how you can represent it in the form of Venn diagram. If you have a universal set, say U, this is a universal set, and it has a set A which is a subset of this universal set. Okay, so this set A, this is a set A. A is the subset of U. Okay, now if you want to find the A complement, what you will do, example, this is a set, it will be represented as this. Now its A complement will be defined as, we'll write again as this is A, this is U, and A complement will be U minus A. It means you have to subtract A from the U. It will contain all the elements of U except A. Okay, so how we will represent it through lines? This area will represent A complement. Okay, so this is how you can represent the A complement through Venn diagram. Let's have a few properties of complement of a set. We have few properties. Then we will move towards this example. Properties of complement of a set. Complement of a set. Let's see what are the important properties. One by one. We have A union A complement. It is equals to universal set. Okay. Then if you have A intersection A complement, you can have the proof also by taking the example equals to phi. A intersection A complement equals to phi. Then A complement, according to the law of double complement, it will give you the set itself. It is a law of double complement. Double complement. You can prove all these properties through example. Okay, then another property is, if you take the complement of phi, it will give you the universal set. Okay, It is a universal set. And if you have a universal set and you take its complement, the answer will be an empty set. An empty set. So these are all the properties of the complement of a set. You can also prove these properties by taking the examples. We will take an example, then we will also prove one or two of these properties for your convenience. Let's see how you can find a complement of a set if you are given with the set. Example is if A is equals to 1, 2, 3 and 4 and U is equals to 1, 2, 3, 4, 5 and 6, then you have to find its A complement. How you will find its A complement? A complement is equals to U minus A. U is 1, 2, 3, 4, 5, 6. Keep this in mind. The set of which the complement you find is always the subset of its universal set. Okay. Minus A is 1, 2, 3 and 4. Okay. We have to subtract A from U and we will get 5 and 6. So the A complement comes out 5 and 6. This is the A complement. Okay. So this is how you can find the A complement. Let's draw its Venn diagram. How you can represent through Venn diagram as this is a universal set. Okay, that consists of 1, 2, 3, 4, 5 and 6, and we will draw A here. This is A, that is 1, 2, 3 and 4. Now we will represent the desired portion by drawing the lines. U minus A will be 1, 2, 3 has been subtracted, then the portion that is required will be like this. This is the required portion of U minus A, that is A complement. U minus A. A complement is equals to U minus A, refers to this Venn diagram representation. This is how you can represent a certain set of numbers by using represent the complement of a set through Venn diagram and in mathematically and through mathematical solution. Now these are the few examples. Let's have one more example. A very simplest one has 2 or 3 examples help in the clear understanding. Let's say A is equals to set of odd numbers. Okay, and B is equals to, it's U. It's not, it could be B or it could be U. It's up to you, but it must be like writing as U for your convenience. Set of integers. Okay, let's find its complement. Means A complement is equals to U minus A is equals to set of integers minus set of odd numbers and A complement comes out to be set of even numbers. Okay, so this is how you can find the complement of a set. Okay, now let's have a proof of few properties of complement of a set as through example. One of the property was phi complement is equals to universal set. How you can prove it? You can prove it as we have to phi complement is equals to u. Let's find its complement as if we have a set A is equals to an empty set, that is phi, and we take its complement. Now let's have a universal set of 1, 2, 3, 4. Okay, let's find its complement as A complement is equals to u minus A is equals to 1, 2, 3, 4 minus A is 5. As there is no element in 5, so we will say 1, 2, 3, 4. It means A complement comes out is equals to u. That we have, this is the same thing that we have said here, that whenever we take the complement of a set that is an empty set, the output is the universal set. Hence proved. This was the property number 1. Now we have another property, that the double complement will give you with the same set again. We take the example of, let's have an example like A is equals to 1, 2, 3. A is equals to 1, 2, 3, and U is equals to 1, 2, 3, 4, 5. And it is clear here A is the subset of U. Okay, then we will find A complement. A complement is equals to U minus A is equals to 1, 2, 3, 4, 5 minus 1, 2, 3, and it will give you with 4 and 5. Okay, then now we will take again the complement of A complement. A complement of complement, it will give you with U minus A complement is equals to 1, 2, 3, 4, 5 minus A complement was 4 and 5, and A complement was 4 and 5, and the answer will be equals to 1, 2 and 3. Yes, so this is A complement is equals to A. Hence proved that when you take the double complement of a set, it will give you with the set itself. Hence proved. Okay, so this is how you can also find the proof of the other properties of the complement of the set, as it is so easy to just you have to take the random example and apply it on that property. So hope so this concept has helped you a lot regarding the complement, what is complement, what is its mathematical representation, and how you can represent it in the form of Venn diagram. Thank you.